I'm Clint Wixson, and this is my second project for Dr. Rashidi's class, Design and Manufacturing. The topic for this project is dye design and manufacturing. Dye design and manufacturing. The terms tool, dye, and mold are often used interchangeably, but they refer to different things. Tool is a general term for implements used to produce other parts. Tools can have a wide variety of functions, including cutting, measuring, assembling, or holding the workpiece. Examples of tools include jigs, fixtures, and gauges. A die is a specialized tool that is used to cut or shape materials. They use pressure to transform a solid piece into a desired shape. Dies are typically used to produce metal parts. A mold is another type of specialized tool. Molds start with a liquid raw material and solidify it into a solid part with the desired shape. Common materials are rubber, plastic, and metal. Both dies and molds use cavities to change the shape or size of an object. The photo on this slide is an example of a die. Dies have a wide variety of applications. Many manufacturing processes involve the use of a die. Examples of manufacturing processes that require dies are forging, extrusion, drawing, swagging, and most sheet metal processes. Because of the number of processes that use dies, dies have applications in most industries in manufacturing. The automotive industry uses dies to manufacture engine components among countless other parts. High quality dies ensure each component adheres to safety standards. The aerospace industry requires dies that can handle precise shaping of uncommon materials. Dies allow for the mass production of many different consumer goods. The medical device industry relies on dies to hold tight tolerances, and the electronics industry uses dies to maintain quality in high volume production runs. Dies can be classified according to function or mechanism. Underneath function, a die is a cutting die or a forming die. A cutting die removes material by cutting or shearing. A forming die reshapes material without removing it. Some dies can feature a combination of both cutting and forming. Underneath mechanism, a die can be a simple die, a compound die, a progressive die, or a transfer die. Simple dies perform one action per stroke. This action can be cutting or forming. Simple dies are relatively cheap to manufacture when compared to other types of dies. This makes simple dies cost-effective for low volume production of simple parts that require one operation to produce. Simple dies are not efficient for parts that require multiple actions. Compound dies perform multiple cutting and/or forming actions per stroke. These actions are performed simultaneously. Many washers are produced using compound dies because the hole in the washer can be cut at the same time. Compound dies have a slower stroke due to the number of operations that need to be completed. However, compound dies minimize errors that can occur when transferring the part to another die and save time overall compared to using multiple simple dies. In terms of cost, compound dies are more expensive than simple dies, but often cheaper than progressive dies. Compound dies are best suited for medium to high volume production of simple parts. Progressive dies use continuous feeding to perform multiple actions at different locations or stations in the die. Each station performs one operation, and one stroke allows all stations to occur simultaneously. Because it is continuous feed, each stroke removes a finished component, while others are being formed. Progressive dies are the most efficient type of die, but have a high tooling cost. This makes progressive dies best suited for high volume production. Transfer dies are similar to progressive dies in that they are multi-stage. However, transfer dies rely on conveyor belts or transfer fingers to move pre-cut blanks through the stages. This allows transfer dies to produce parts that are too large or complex for progressive dies. Transfer dies can be complicated to design and expensive to produce due to the complex transfer mechanisms. This makes transfer dies best suited for high volume production. Most dies have these common components, although each die is different and may include things not listed here or exclude some of these listed components. The die block has holes and indentations that correspond to the shape of the part. The die holder supports the die block. The punch is the part of the die that descends into the blank and provides the needed pressure to deform the part to the desired shape. The punch plate attaches the punch to the ram, which is responsible for its movement. The stripper plate is used to ensure that the part is removed from the punch after completion of the stroke. The guide pins are used to align the upper punch and lower die block parts of the die. Pressure or backup plates are used to distribute the extreme pressures that the punch provides. Die design starts with part design. Parts should be designed with manufacturing in mind. A major goal should be to minimize the number of dies needed to produce the part by using progressive or transfer dies when needed. A die should utilize standard components as much as possible. Computer-aided design and simulation are very useful in die design because they allow for quicker and more accurate design. Some general die design tips are use appropriate cross-sections and clearances, avoid potential stress concentrations, use segments and inserts that can be replaced when worn instead of replacing an entire die, ensure proper surface preparation and finishing requirements are met, and design for metalworking fluids. Some metalworking fluids contain additives that affect common die materials, so these materials may need to be avoided in certain situations. Dies are manufactured using many techniques. Most dies start with a forged or cast base that is machined to the proper specifications. Grinding is often used because dies need to be held to tight tolerances. Electrical discharge machining, or EDM, can be used to create intricate shapes accurately. Heat treating is used to improve the material properties of dies. This is the manufacturing layout of the Fiat Chrysler automobile's Mirafiori die shop. The dies are machined in the green area and assembled in the red area. The blue tryout area allows the dies to be tested to ensure they produce quality parts. The quality area is used to take the needed measurements to ensure dies meet all specifications. Dies can fail for many reasons. Improper design, defective materials, improper finishing or heat treating, overheating, excessive wear, improper installation, and misuse can all damage dies. It is important to take steps to reduce the chances of any of these factors causing die failure. Many die failures can be prevented by using good design and taking proper precautions. The economics of dies depend on the complexity and size of the part, but in general, dies become more economical as the quantity of parts produced increases. This is because dies have high initial cost but relatively low ongoing cost. As the volume of production increases, the cost of the die can be averaged over more parts, making each part cheaper. The die industry is currently going through several trends. The use of automation and 3D printing is increasing. Automation reduces the cost of producing dies and is being investigated for designing dies. 3D printing is used in prototyping, and metal 3D printing may eventually be used in production of dies. Manufacturers are seeing a need to introduce more sustainable practices, such as using recyclable materials, implementing energy-efficient processes, and reducing waste. Trade policies also affect the die industry. Dies are used to make parts economical for mass production. Die design and manufacturing has wide-reaching applications across many manufacturing processes and industries, including the automotive and consumer goods industries. There are several types of dies, including simple, compound, progressive, and transfer dies. Progressive dies are the most efficient but cannot be used in all situations. Increasing automation is a current trend in this industry. These are the references used for this video. Manufacturing processes for engineering materials. What's the difference between tool and die? Die manufacturing definition types in the die making process. Identifying the cause of tool and die failure. Die manufacturing process. More references include how dies are used and what types of dies are available for the manufacturing industry. Mastering the art of tool and die manufacturing, a comprehensive guide. What is tool die manufacturing, a comprehensive guide. Automotive stamping, die, and assembly manufacturing tooling, and finally progressive die, the advanced level of metal stamping. Thanks for watching this video. I hope you're now well informed on the topic of die design and manufacturing.